So, polar form, a very, very fundamental concept in complex numbers. So, if we imagine we have z equals a plus bi, and we have this angle theta here, which really just means the argument of z, but we're just going to name it theta for now. And the modulus is also just referred to as r for now, just to make this explanation simpler. So, we realize that if we draw this triangle, it would look something like A and B, just like that. And what I'm going to do is use this right triangle and theta to build trigonometric identities. And this is going to look like this. Cos theta is going to equal to A over R, and sine theta is going to be equal to B over R. And what I'm going to do is isolate A and B. So this is going to be R cos theta, and this is going to become B equals R sine theta. And what can we do with this? We can actually replace z equals a plus bi with these trigonometric identities. So this is going to become r cos theta plus r I sine theta. So that's a new way to represent a complex number, and this is what we call polar form. And it turns out, as long as you have r, which is the modulus of r, and theta, which is the argument of z, we are able to find the complex number. So this is also represented as r cis theta, where r cis theta just expands to that. And that's also polar form. Another form that you need to know is called Euler's form, which is represented like that. So the same two unknown variables, r and theta, into here. So let's take a look at an example. Express 3 square root 3 over 2 plus 3 over 2i in polar form. So recall that polar form consists in r cis theta. So our job is to find r and theta. Now r, in this case, is going to be equal to the modulus of z. And I've let z equal to this expression just to make our lives easier. And to do this, we know that this is really just the square root of 3, square root 3 over 2 squared plus 3 over 2 squared. So if we quickly do this, this becomes 27 over 4 plus 9 over 4, which becomes 36 over 4, and that becomes 6 over 2, and that becomes 3. So we know that the radius, or the modulus, is equal to 3. Now we are concerned to find theta here. And now I'm going to recognize that this is actually a special triangle. And as you can see, 3 over 2, and this is 3 over 2 times square root 3, and this is really just 3 over 2 times 2. So I know that theta has to be equal to pi by 6. So, therefore, 3 square root 3 over 2 plus 3 over 2i can be expressed in polar form as 3 cis pi over 6. Very, very simple. And what I'm going to do for the sake of your understanding is just verify this. So this becomes 3 cos pi over 6 plus sine pi over 6 I, right? And cos of pi over 6 is equal to square root 3 over 2, and pi by 6 is equal to 1 over 2 I. And as you can see, when we expand this, this is indeed true. So that is polar form. And if you were to write this in Euler's form, it's very simple as well. You would just get 3e to the I pi over 6. And you have to know how to recognize this form, but it's not very often used. Just always use polar form, because it is the goated formula.